Welcome to my free Java video course, Lesson 8. My name is Markus Biel. My goal is to teach you Java in the easiest possible way. For feedback, send an email to info@markus-biel.com or a tweet to @markusbiel. Today I would like to introduce you to loops. This is really exciting because it's a very cool feature. It allows you to execute a repetitive task much faster than any human could do. So this really makes our programming very powerful. So it's very important to know how to program loops. However, as always, I'm going to recap what I showed you in the last lesson. Before, however, I would like to thank Sabino from Italy, especially for his feedback that he sent to me from my website. He wrote, "I would just like to congratulate you for your free lessons on Java." So guys, just keep the feedback coming. This really motivates me on keep doing this course for you. Also, if you can tell me like what I can improve, like should I make the lesson slower, longer, or shorter? Whatever. I mean, I'm really happy about any feedback you send me. Keep it coming. Okay, so now enough of the feedback. Let's dive into the lesson and let's see what I showed you last time. So last time we talked about booleans and if and else if and else. In the meantime, I've adjusted if statements a bit because I also wanted to show you, I think I said it, but now here you can see how it's done. So you can have a method should drink beer, you forwarded a few parameters, and then here this calculates what kind of boolean, true or false, is returned to the caller, which is in this case here line 47. And this then defines if we will drink a beer or not. Also, have a look here for the if, else, I mean, what I wanted to warn you a bit, because you see this is quite big, and the longer it gets very hard to understand. So try to keep your if statement small, and whenever you have an else if or else, think of a way of how you can like go without it. I will later on also show you a few possibilities. I mean, but for now, just introducing the if statements. It's okay if you just know, yeah, that sometimes they're not so readable and you should find a way of like avoiding them. For example, one thing here, which might already be a bit better, is here I put two ifs after each other, which can run by themselves. So if you look at the second if, all you need is you need to understand this if. I mean, it could also have been programmed like that, but then this requires you to understand this if to understand the else if branch. So if possible, if you can do it like this, this can also make it already a bit easier. Also, you could have several layers of ifs. Inside an if, you could add another if, and so on. Just don't do that. I mean, the harder it gets to understand something, the easier it is to introduce a bug. And yeah, bugs are evil, we don't want them. So try to avoid that. Also, one last warning. I recently read something, I think on Twitter or so. If possible, try to avoid the else specifically, because all the else says is if none of these branches apply, so if we're not going here, here, or here, then go here. What we could say instead is if this other condition applies, I mean, we would have to write a method or some statement, which I don't know at the moment, then execute this j minus minus. So there is always an alternative. You don't necessarily have to do it in the else statement. Okay, so remember, this is the OR, these two pipes, the equals with two equal symbols, the greater, the not equal with the exclamation mark, and yeah, so Boolean, this primitive data type I introduced, can be true or false. Yeah, I think this pretty much rounds up what I showed you in the last lesson. Now let's continue with loops. Or maybe I should also mention, I mean, there are other conditional statements, for example, the switch statement. I was about to give you a lesson on the switch statement today, but then I realized for the switch statement, I would first of all like to introduce you to enums, because they play a big part with switch statement. So I'm not going to do this today. So instead, we're talking about loops today, which is really a cool feature, like I said before, sorry. So what I did is, from this test above here, I just copied the whole content, because today I want to do the same test just using a loop. Because you see, 4 times I created a person object, so this is a repetitive task, and I would want to do this more easily. And when I prepared for this lesson, I noticed the following. See, I execute this test, and it's red. Ooh, seems like I've done something wrong, and I've just noticed it then. So if you see what I did in a previous lesson, it seems like I introduced a bug. And I wanted to show you this because this is really a good reason why we have tests. Because without this test, I would have maybe never realized that I've introduced the bug. So let's debug. Let's look into the code, what's going wrong here. So whenever we create a person, we call this person constructor, and here we had this person counter plus plus. And I told you that what would happen is person counter is incremented by 1 and then assigned to person counter. Well, actually this is a lie, because it's slightly different. The thing is, what happens here is the plus plus is at the right side, and this makes a difference. What is also possible, it could be on the left side, which is a different statement. Now let's see. It was at the right side, and that means take the value of person counter and assign it to the left side, which is person counter. So this is like, remembered that at the beginning it's 0, and then increment plus plus person counter by 1. But still we have the 0, which gets assigned here. So actually person counter is not incremented. And as you see here, actual 0, it stays at 0. So this is a bug. To fix it, we can either do the plus plus at the left side. Actually, not many people know even that you can do it at the left side. And this means, first of all, increment it by 1, and then read the value. So the value is read after it's incremented. And this is what we want. So this is the correct code. Alternatively, of course, we could also do it in the easy notation, just person counter plus 1. This should also work. But I mean, this is my assumption. Let's test it. So I'm going into the test again. I'm running the test. And now it's green. Let's do the same thing with plus plus on the left side. Execute the test again. and now it's green again. So either of them works. It's just that the plus plus at the right side, this did not work. Okay, good that we found the bug. Great that we had the test that found this bug for us. So now that this test is running, I assume my copy of the test is also running, but let's verify that. Okay, so before we start to refactor the code, we see we have a green bar, a test that is working. So whatever we do now to the code, the test should stay green. Okay, so I told you I want to do a loop today. So what actually is a loop? A loop is like a loop, a loop, a loop, a loop, a loop. Yeah, so it is repeating something until a certain condition comes true. So there are certain different types of loops. The first one is the for loop. For because it says like for a number of times execute something. So this is what for. And then, sorry, this writing here will be a bit cryptic. I'm sorry. The reason is because this loop is really also a very old loop that was also introduced before Java actually. I think it, for example, is part of C and C++, which are much older than Java actually. So when they invented Java, they just took over the same style. So this is why it's a bit cryptic. So we have 3 sections here. Let me first of all type it and then explain. So this is the 3 sections that this first loop usually has, which means first of all introduce an int and assign it a value of 0. Calling this variable I is like the default because I just for integer, because the guys that invented programming most of the times are also mathematicians. So yeah, they really like short variables like I, and as it's so common, I also used I, but you could also call it like counter. It's just that people would expect you to call it I. In this type of loop, it's mostly always called I, or just Y, or some variable short, just one letter. Okay, anyway, so this is our counter variable that defines how many times we want to execute a certain statement. Our statement that we want to execute is actually that create a person object, and we want to do this 4 times. In programming languages, again, mathematicians, they're to blame. They don't start with 1, but they start with 0. So if we want to execute it 4 times, we have to make sure that that I stays smaller than 4, because from 0 to 3, this is 4 times. And each time when we're finished at the end of the loop, I is incremented by 1. See, this is the plus plus. So afterwards, it's incremented by 1. And then in the next round, it will be 1. 1 is smaller than 4. Next one it will be 2. 2 is smaller than 4. 3 is smaller than 4. And 4 is not smaller than 4. So for the 5th time, the loop will be exited. And so afterwards, the code will be here, the cursor kind of, and we will not execute it a 5th time. So I copy this into the for loop. And then this should make sure that 4 persons on the fly are created. Actually, because this variable is defined within the block, we cannot access the person object anymore in here. I think I showed you this. See, it's red. This is about the visibility. What we could do is we could put the definition of the variable up here. This way we can still access person 1, but actually only the last one, because the variable person will always be overwritten by the next one. I mean, for this little test here, this is okay, because all we want is we want to calculate the number of times the constructor was called. So this works, as well as we could also define person in here. Doesn't make a difference in our case, because this is a static method. We talked about this in an earlier lesson. So now let's try that code. And it's green. Now let's try it to put a 10 here. This does not work, because see, we expected 4, but actually there was 10 times the person constructor was called, because this is 10 here. So this is how the first loop, the for loop, the regular for loop usually looks. You define an int, you give it a one-letter name like I, you assign it 0, and then you compare it to some max value, in this case 10. Before we had 4, so that the test is green again. You always have to separate these blocks with a colon, and then you increment I by 1. You can also do any other statement in here, like you could say I equals I plus 2, which will then, let's see, let's not assume something. See, now we only created 2 persons, because each time it was incremented by 2, which means the number of times that we were going through the loop was only half the number, of course. And if we add 4, or even, I don't know, 10, we will probably only execute it once. Let's try that. Yeah, see, actual 1. Okay, so usually you could put any statement here, but the default is you just increment a counter variable by 1. So really try to stay with the default and do it like this. I could even further tell you crazy stuff, like you don't even have to do all this. You can have this empty. This now would be an infinitive loop. You can try this at home, because this will like probably crash your PC, because it will create lots of objects. But it is valid. Okay, but this is how it should usually look. So anyway, let's go to the second loop, which is the while loop. While some condition holds true, execute. And each of these loops have their specific reason to be used. I mean, actually, in theory, you could use always just the one loop, like this loop or that loop. It's just that when you want to count something, I mean, this really is helpful, because it does everything at once. If you want to do exactly the same code, we have to do it like this. Int I equals to 0, while I smaller than 4. And then you have to say at the end I plus plus. So this is exactly the same, and you see it's not so nice and short anymore. So this while loop you would usually do when, for example, you have some condition that gets dynamically calculated, like we had the function here, should drink beer. So if you had some function here, like should drink beer, this is when you would use a while loop. I mean, I have not defined those variables here, but I hope you get the idea. If you have some function that is always calculated, you would use the while loop. And then in here, you could also create the person. And you don't have to do this now, because we assume that this method sometimes would return false, and when it returns false, this loop would be exited. Okay, but let's go back, because I actually want to run it once. And there is a bracket missing. Because I promised you we can do exactly the same thing. So let's try that. Okay. Well, this probably will not hold true anymore, because then we have done it 8 times, so let me remove that code. Okay. Let's check. Seems okay. Let's see what JUnit says. Okay, seems like this is okay. So it's the same one. And then, last but not least, there is also another loop, which is called, this is the newest loop, because it was introduced, as far as I remember, with Java 5. This is the most simple and the coolest loop. However, I'm sorry I cannot show you this one, because for this I need to introduce you to arrays and collection, which I will do in one of the next lessons. So for now, just know there is another loop, the coolest one actually, but yeah. So this was a very short introduction to 2 different loops. Well, actually, yeah, I could also show you the while loop. You can also do it kind of, let's say, backwards. So you can say do while some condition. The regular while and the for loop I showed you, they're very common both. But this one you will hardly ever see, because again, it's a bit more difficult to understand. What it does is it executes this statement the first time, without even checking a condition. So the condition is checked only afterwards. Of course, we also need to increment. Okay. So what we do here is we assert that number of persons equals to 4. Well, no, this is this won't work. We have to assert it afterwards, sorry. So now we create the first person without even knowing how many times we have created it. Then we increment I, and at the end we check that I is smaller than 4. Let's try this and remove that. See, this also works. This depends on the logic that you need. Sometimes you may use that, but actually all the 3 different loops I showed you, they are like equivalent. You can do everything with each of those loops. So it's just a different style, and this depends on what you want to express, what is easier for you to use. This you will get used when you're like did a few months of programming and you used each of them, you will get the hang of it, what's like usable in which situation. Okay, so far about loops. I will, as I said, extend that at a later time for the coolest loop, the for each loop. Also about the conditional statements that I showed you. There's one more thing I have to show you, which is the switch statement and the enum. So see, there is a lot of cool stuff that we still have to talk about. So see you in one of the next lessons. Thank you.